Okay, good day, grade 8 Math and Science High School students. We are on our 6th lesson for the first quarter, the 6th and the 7th lesson to be precise. So we're on area and perimeter and surface area and volume of 2-dimensional and 3-dimensional figures. So let's jump right ahead with our first problem. A cube of edge 6 centimeters is immersed in a rectangular vessel containing water. If the dimensions of the base of the vessel are 15 centimeters by 12 centimeters, what is the rise in the water level of the vessel? Okay, so let's try to illustrate this problem. We have here a water vessel. Okay, so we don't know what shape it is, so maybe it could be like a rectangular cuboid. Okay, this water vessel that we have here. Okay. And in this rectangular vessel, the dimensions of the base are 15 centimeters. So this is 15 centimeters and this is 12 centimeters. Now, there was a cube that was immersed, or that was put inside of this cube. Let's say that this is the cube that was put inside of the cube. Okay, so it says here, one of the clues, the side measurement of the cube is equal to 6 centimeters. Now, if we put something that has water inside of the container, so there is a chance that the water level will increase. We call that displacement. If you recall in your grade 6 or grade 7 science and technology subject, so if you place a metal object, especially something that sinks inside of a vessel, so there will be water that will be displaced, or a liquid that will be displaced, that will cause a significant rise in the water level. So for this problem, that's what we want to find. For this problem, so our first clue is that the base is equal to, it has this dimensions 15 by 12. So if we want to find the area of the base, what's going to be our formula for finding the area of the base of, let's say, a cuboid? So that's just length times width, kind of like just finding the area of a rectangle. So that's 15 centimeters multiplied by 12 centimeters. 15 times 12 is simply 180. So we have here 180 squared centimeters. That's the base area. That's the base area of our rectangular cuboid. Now, given again that a cube was immersed or was submerged in this rectangular container with water, so for this problem, we can say that the volume of the cube will be equal to S cubed, and that should give us 6 times 6 times 6. And with 6 times 6 times 6, so that's 36 times 6, which is 216. So that's 216 squared centimeters. Now, what are we trying to find here? We're trying to find the increase in the water level. So how high did the water rise when this cube was submerged into this vessel? To find that, we'll have to go back to density, to the formulas for density. So if you submerge something and there is a specific area on that part, so the amount of water that would be displaced would be indirectly proportional to the base area and the thing, or the volume of the thing that you just submerged into that vessel. So for this one, in order to find the water level that has risen, okay, so the water level that has risen after submerging the cube, would be the quotient of the volume of the cube and the base area of the cuboid, or the vessel that we have here. Since we know that the volume is equal to 216 squared centimeters, and the volume is equal to 216 cubic centimeters. That should be our unit. 216 cubic centimeters. And the base area is equal to 180 squared centimeters. So these cancel out. What we have would be a unit of centimeter, 1 unit of centimeter here, centimeter raised to 1. And what's 216 divided by 180? So that should give us approximately 6 over 5 or 1.2. Okay, so therefore, the water level rose 1.2 centimeters when the cube was submerged into the vessel. So this was the height. This was the change in the height, or how high the water level rose when we submerged this cube into this vessel. And again, this has applications in density and displacement, water displacement on liquids. Okay, and that's how we solve this problem.